Just let me know if the presentation is.
Yeah, your screen is already on.
Yeah, yeah. Thank you. Thank you all. All right. The topic when I've asked, I've chosen it as applied AI. Actually, here nowadays we keep talking about AI ML. Being leading the department of AI ML and IoT, I still have my own things. Why do we call it as AI and ML? When I look at AI in a bigger picture, ML or DL or your data science, to some extent, I don't say the whole of data science and NN, they all are part of applied AI. That is the reason I just mentioned that we'll go with the topic like what is called as an applied AI. So I would be talking about AI, how it is in practice, and we'll be looking at the relationship between AI ML and what are the definition and features of ML machine learning techniques. And I would like to project on one of the applied AI technique, that is K nearest neighbor. Probably you all might have seen that. I would just like to work with one small data set and show you how we generally go, do a small project on that using your ML technique. Now, when we actually started AI, so what exactly is your AI? It is the capacity where you are trying to learn and solve problems. How is it different from the conventional programs that we do? Here, we are trying to simulate your human intelligence by machines, like the ability to solve the problems, to act rationally, logically, and then you are acting like humans. So all these things is part of your artificial intelligence. There are many games which has come up. One of the game, for example, you can see is your tic-tac-toe problem. This problem has been very famous even now, right from the school students to the undergrad students. I keep watching students working on this tic-tac-toe, maybe using linked lists or using pointers, structures, or they may be writing the code for this in Java. So this is where you are trying to make your machine little intelligence. Likewise, the chess game is also one example where AI has come in. This is in the early days where AI came into practice in this particular way, where you have all your what do you call, all your logical thinking or your rational thinking you have embedded into the machine in the form of some set of rules or some set of methods or functions, and then that is how you are trying to play this game, right? So this is how your AI initially started actually. And then what are the basic things or the important parts of your AI? The search strategy is one thing in AI that plays a crucial role. My search problem, it will consist of the state space where it will have all the possible states where you can be. Your start state till the goal state. In between, you can have many possible states, and the solution for your search problem will be that sequence of actions that will transform right from your start state to the goal state. Whatever is the sequence of actions you have, that particular plan, that plan is achieved through your search algorithm. So now, when you look at your search in AI, this is many of us are familiar with few algorithms. You have an uninformed search and you have an informed search. When it comes to uninformed search, you have your BFS, DFS, brute force search, and greedy search. And informed search is your heuristic search. You already have some knowledge about the problem. I am trying to embed that knowledge or append that knowledge which will bring you to your different informed searches like your best first search, branch and bound, A star, AO star, hill climbing, and then and further more you can even have constraint satisfaction search, means and analysis, simulated annealing. Most of them which if you have taught artificial intelligence, you might have come across all these things. Particular search that I'm showing here is your BFS, which we have all come across in data structures, design and analysis of algorithms, and elsewhere in many places, right? So this is one of the search strategy that you have. That is your BFS traversal. Like that, you have where it is totally uninformed. I don't have any knowledge about the about the problem. I am just blindly going with one particular way where I traverse level wise. Okay, you try to go with one first level, then second level, third level. So you are just traversing level wise. This is your BFS. When you go with your depth first search, you are trying to traverse into one particular in-depth way line you are traversing. But when I come to heuristic search, probably uh, I have some sort of knowledge already given to me. Some estimated values are given to me. The value to go from your start node to some intermediate node, and from that intermediate node to the goal node. So some estimations are given to me, and based on those estimations, I will try to do the search. Those kind of searches are where you have your knowledge involved or heuristic knowledge involved. Okay. Now, what are the goals of AI? Here, I would like to develop algorithms that humans can use and where my machine can act like humans. Okay. For this, maybe I need to have my machine understand the data, the knowledge to be represented, some sort of common sense to be put into the machine. So these are few things which you look upon when you look into your AI. And also the execution of planning, the sequence of actions, how they will lead to some specific task. How am I going to plan that? And when there are multi-agent planning, where you need to, where these many agents, they try to cooperate and compete to achieve the given goal. And also the learning technology. When it comes to learning, now this is what I'm saying. When I say applied AI, the learning involves your machine learning or deep learning, which is again part of your AI. So machine learning is the fundamental concept that is behind your AI search, all the different search strategies that you are seeing. I have unsupervised learning and supervised learning. In case of unsupervised learning, I am not aware of the pattern, the labels, whereas in supervised learning, I know the labels, the classification. I have various classification techniques which are involved here. One of the example of your learning is differentiating your spam messages from your inbox actual messages. This 8 puzzle problem, like your tic-tac-toe problem, this is one particular learning that you have where you can move up, down, left or right. Okay, so these are the different things, scenarios you have. Now, this is one search strategy. This entire thing is your search space, and my search space consists of when I want to move. I mean, what are the different ways I can move to the left? I can move to the right. I can move bottom. I can move down. So if I move to the left, from there again I have two different ways. If I move down, how many alternatives I have? If I move right, up, what are the two different ways I have? Like this you keep doing. But this is a blind search that you are doing here. If I can add some heuristic, how many tiles are not in the right position, if I can count on that, and if the number of tiles which are not in the right position, the count for which it is less, if I take over from that tile, probably that would make me go towards an easier, with some heuristic knowledge, with some sort of knowledge about the problem I move, that would make things much easier for us. So that is what is your heuristic search, or you are having some sort of added value, added knowledge to it, which will make your search strategy easy rather than moving the whole search space and trying to come to the solution. Now, when I look at the search strategy, now for the same example of your 8 puzzle, this is the basic terminology that you look upon. How is the location of your tiles? What is your initial state? So what are the successor functions you have? The 4 functions that I have is move left, right, up and down. And finally, what is the goal state? And each step, when I move up or when I move down, or when I move left or when I move right, how much cost is it taking me? Each step is costing me one moment, one thing. So this is the basic terminology based upon which I try to do the search strategies, or I work upon the search strategies. Another component that comes into picture when I talk about AI is your expert systems. In the expert systems, you have a human expert and a knowledge engineer. A person who's not an expert, he will try to interact through the user interface. Okay, from the user interface, whatever he asks for, that is sent to the inference engine. From the inference engine, we'll have a mutual data exchange with the knowledge base that is already available, and with the opinion from the expertise, taking in all this into seeking all the information and the relationships from the knowledge base. Then it would try to provide the answers or the predictions in a way how a human expert would do, how a human being given a question, how what could be the answer, or like when I'm playing chess, what would be the next move by the opposite person, or what move am I supposed to do at this point of time. So these kind of things, it is like mycin is one expert system that was developed. And so this kind of expert systems, they are very useful um, for real world problems, which if you have enough data with you, if you can develop, then it would really be useful. So now, like as human beings try to give, this was one chaining expert system which I talked, mycin, and it was used, yeah, it used artificial intelligence to identify a bacteria like causing several infections like meningitis, or some bacteria related infections, where using mycin expert system, they were recommending antibiotics, and with the dosage that is needed based on the patient's body weight and all. So this was developed way back to treat infections, that is through for bacteria. This was just making use of your knowledge base and the inference engine to finally infer few things out of it, to predict the answers and to provide the answers. So this was the early stage where AI has already developed, or was already involved into healthcare, where it treated blood infections using, this kind of expert system was already developed way back, long 1972 itself. They began to work on mycin actually. Okay, so this is how an expert system components work actually. Now, what are the various applications? You all are familiar. Yeah, it helps. It is used in healthcare for assisting doctors in our education, for auto grading system, autonomous vehicles, overall process to work smoothly in business. You can use for pricing pattern, social media for serving personalized this. So it is being used in the application of AI is very vast. Now, the current scenario today, the AI that we are working on, probably at least until last 10 years back, we were just working on AI and we were looking into NN. But NN was not that successful until your GPUs and all these high-end high-end storage devices and computing power has come. So after that, now NN has completely transformed the world, we can say. So till then, we were just learning with AI, and probably we were learning little with expert systems. We were learning with search strategies. We were also learning with some sort of gaming problem solutions. Okay, but today's scenario has changed from the current scenario. When I look at AI as an applied AI, when you look into it, so I have deep learning and predictive learning, which are again part of your machine learning. When you come to NLP, natural language processing, you have so many BERT analysis, LSTMs. I have so many inbuilt Python libraries are available, where I can use for translation, classification and clustering, information extraction, IRE, where you have all your documents. You have different models into which you can do represent your documents, like your Boolean representation, term frequency IDF, and then you can make use of ontologies, wherein you can what do you call you can make use of software like WordNet. So all these things can be used, which are part of natural language processing. And then you have speech to text and text to speech conversions. That is another speech recognition systems, where again AI is part of AI. Expert systems as one example, which I've already told, mycin. And then robotics is part of it, planning, scheduling, and optimization. And then the most important thing, where you have your image processing, and your machine learning involved is your computer vision. So computer vision is one thing which has picked up in the market like anything, and this is an interdisciplinary scientific field which deals with how computers can gain high level of understanding with your digital images. So here you are dealing with digital images, and then you try to automate the tasks in with your human visualization system. Probably reinforcement learning is also one of the thing which is involved here. So this is all. This is the current scenario of AI, which I call it as an applied AI. Okay, so. And I believe each of this is machine learning is part of every PhD project or every BTech student project who's working with AI/ML. All the algorithms of machine learning, supervised or unsupervised, you are making part of it. But then when I look at NLP, whether I work with NLP or whether I work with speech recognition or whether I'm working with computer vision, finally again I deal with all these kind of algorithms. Probably the feature reduction and the feature engineering kind of techniques may change. Okay, in NLP, yeah, maybe I try to extract the words, I try to do with sentiment analysis, or I try to build a knowledge base. I work with different kind of things. But then again, here also I make use of make use of machine learning and computer vision. Definitely all the meaningful information from your digital images or the videos or any sort of visual inputs, and I can take actions and make some sort of recommendations from based on the information that I extract. So that would be really useful and a wonderful thing to work with uh, in the media technology that we have. Okay, so this is a bigger picture of AI in the current scenario, which with which we can say that it's no more simple AI, it's an applied AI involving all these things in a bigger picture. So narrow AI, it was just dedicated for one task, and then general AI, probably it used to behave like humans, like your chess program and all these things. And then when I look at super AI, which is intelligent than human beings, you can look at your robots and all these things. Now, when narrow AI, yeah, your autonomous driving, and then when I look at artificial general intelligence, human task, and better than that, artificial super intelligence, I believe your robots are one example. And then in today's current scenario, my applied AI applications you have with Alexa, Google Assistant, which you all have been experiencing, right? And then Netflix movie suggestions, recommendations, probably Amazon products. And if I'm moving to some place, if I'm trying to book a flight ticket, I get my own recommendations on the prices. And then your modern cars, where anti-lock brakes kick in, and then you are to separate your spam filters, commercial aircrafts, Google self-driving cars, Android phones. Is it that I have my AI is limited only to these particular things? No. If I look at the other disciplines like engineering, probably in civil engineering, the structural engineering, where I can make recommendations about the healthiness or the strength of the structures of your related to your structural engineering. So there I So this has become an interdisciplinary. Ma'am,
Ma'am, you were not muted, but then your voice was inaudible.
am I audible?
Yeah, yeah, now okay, ma'am. Hello, ma'am. Ma'am, again, your voice is inaudible, although you're not muted. Participants, sorry for the inconvenience. Ma'am would be joining very shortly. Ma'am, I made you the presenter.
Yeah, I got it. I'm sorry. I hope I'm visible. I mean, my presentation is
Yeah. Your
visible,
screen
right?
is on,
And I'm
ma'am.
audible too.
Yeah.
I'm sorry. I'm extremely sorry for the
No issues, ma'am. It
inconvenience.
happens.
Yeah. Okay. So yeah, I was talking about the interdisciplinary thing that we have. So when we look at AI applications, it is not that only in our technologies or in the day-to-day things that we do, but I see that in my college we work with this technology with mechanical branches, civil branch, ECE and EIE. So it's like your machine learning applications or your applied AI applications have gone very wide, and they have a very larger and wide scope. We see their applications everywhere. So like one example which I was just talking about is structural engineering, where we need to know the health of the structure of that particular project. There we can make use of machine learning. One of the project which I myself have worked on in knowing the properties of steel, so generally the steel is like carbon, based on the carbon content and many other factors like tensile strength, yield strength. You try to predict the properties of the steel, but every time it has to go through that heat furnace, and you have a tabular logarithmic kind of things that comes up based on. I mean, you try to look into the log tables, and then you write down your tensile strength and all these things. But then if we can automate making use of your machine learning techniques, if we can automate find a tool that is automated, which will let you know the properties of different metals, not only steel. I worked with steel, but probably you can do it with other metals too, where you can predict the properties of that particular metal. If I can make use of machine learning there, this is something where which is connected with the mechanical engineering department. So the what I mean to say is your applications are very wide. Using AIML applications are quite wide. Now, when I especially look at AI applications in healthcare, has been very crucial, like your personalized treatment, smart electronic health records. This is very important. Countries like Canada and Germany, all these people, they have smart electronic health records, which give them lots of data, and they're able to work with various machine learning algorithms on that and try to come up with some sort of healthcare expert systems. And then it can be used like one of the example, your COVID 19 that we have been already, where we have gone through lot many things. So this kind of epidemic outbreak predictions, discovery, clinical trial research, the radiology department, disease identification. So these are few applications in healthcare, and this is a very crucial industry, your health industry, where AI applications have intense or immense impact. Now, when I try to understand the differences in your AI concepts, so this is the bigger scenario. I have AI where you are trying to make your programs able to learn and reason like humans. I have machine learning, which is part of this, where you have algorithms without being explicitly programmed, and you have your deep learning, where you have AI. I mean, you have artificial neural networks, which will adapt and learn from vast amounts of data. When you look at the traditional or conventional programming, what is it? You just give your input and you get your output. But then when I look at the programming with machine learning, I take the results that come out and the input plus results that is going to give me some sort of prediction or answer. So that is the difference between, like, if I write a C program, I write a Java program, how does it differ from a machine learning program or your artificial intelligence program? What way does it differ? So here you are just going with what is called as conventional programming. I write some sort of methods or some sort of conditional statements, macros, or maybe functions and procedures. I make use of them, and then I try to get some output, result. But here it is not like that. I try to embed some sort of logical reasoning based on all the results that we have. I already have some knowledge base. I already have some input embedded with that particular problem. I take that expertise knowledge and then I take the input. I work together. I work making use of my expertise knowledge. I work on the input to give the respective predictions or the answers or the output. So this is how your conventional programming and your AI programming differs. When I look at machine learning, which is a subset, it makes use of computer algorithms making intelligent decisions. Here I try to train your large sets of data, and then using this large set of data and learning from various examples which are already pre-programmed into my machine, I come to some sort of conclusion. As the previous session, when the last slide your madam mentioned, definitely your neural networks, I go through many layers, layered neural networks to simulate your human decision making. This is what I was talking about. Your conventional programming, I'm just giving my program, a data is given, and your result comes out. But when I look at your machine learning, you have your result. I mean, if you look at this, you are trying to take the knowledge, the expertise knowledge, or the result which is already there. I use that, I apply that on my data, and I come out with a program. I come out with some set of instructions. Now this program now is a standard one. Now you try to apply this with various other kind of problems for the same application. It will lead you to the correct predictions or the correct answers. So that is how your conventional programming differs from your machine learning program. So this is how your traditional program works. I'm giving your data, I give some if then else set of rules, and then I get output. But then here I already have the answers. I have some knowledge. Like suppose if I'm dealing with a cardio patient, I know what is his BP, what is this. Apart from that, what is his hereditary, what he has done in the past. All these kind of other knowledge I try to put into it, and then I work with the algorithm and I come out with some rules. And my rules going forward, if I have worked with XYZ, then this rule a database that I develop after applying machine learning algorithms that which wherein I have used XYZ data. Now these rules, if I apply for ABC, it is going to give you the correct result. So this is how your what do you call, your conventional programming differs from your machine learning kind of programming. Okay, so you are learning from the experience. Automatically you try to improve the experience. Like a child, how is he learning your specific images, or he is trying to identify and differentiate between them. In the same way, machine learning also, through some sort of input data, certain commands, you try to enable or identify, distinguish these objects. And maybe one of the learning that you can talk here, I mean, when I talk about machine learning, I would also suggest one more one word, which is called as reinforcement learning. So reinforcement learning, this is one area of your machine learning, and this is like an intelligent agent which is interacting with the environment, and it tries to learn to act within that. The best example for the reinforcement learning is your robots. The robots mostly the science of this is like a decision making science, and the optimal behavior you try to analyze in that particular environment. So robots are one example. Of course, you are making use of this reinforcement learning in games, in simple game strategies. And then Google has applied this for many games actually. It is used even in the healthcare recommendation systems also. Nowadays we are making use of what do you call, reinforcement learning, which is trying to learn from the experience. Basic framework of your what do you call machine learning. I have a output which is based on some sort of feature representation you are giving, and then I apply some prediction function. You're training that, and you try to come out with the test value. And the feature reduction, feature engineering techniques. I have many feature engineering techniques which I can apply. One example, supervised learning classification. Like here, you can see X is my sample, and then I'm trying to classify my X into Y, which could be which could be, I mean, a fruit. So here it is trying to learn the rules for recognizing the fruit type. And after learning, I try to, using the learned knowledge, I try to I try to train my this, and then you have a train model, which will try to predict the, what do you call, the fruit, the new instance. I mean, based on the any new instance, first initially I try to predict the fruit kind, and whatever I get, I try to assess that or evaluate that. And once my evaluation is like above 95 or 96 to my satisfactory level, whatever you have defined it, then I try to apply that even for your new instances that are coming up. So now this is how, what I'm saying, the general machine learning flow that you have. You use some sort of feature representation, and then I make use of a classifier once a feature representation is done. Like for images, I make use of fixed pixels. If I'm working with documents, text documents, probably I make use of some vector space representations, like that. Various kinds of representations you have. Once I do that kind of representations, I make use of my classifiers. Here, as I'm talking about supervised classification, I'm I may use a k nearest neighbor, or I may use a naive base, or I may use SVM, I may use random forest. Any of these supervised techniques I can make use of, and then once I use all this, I try to bring out some rules, and then I try to evaluate these rules. Evaluation of these rules, I mean, whatever I have made, how to what extent the evaluation is correct, 90%, 95%. Um, like you make some predictions, and the predictions, like if I have made 10 predictions in which 8 predictions are right, so like 80% your analysis is right. In the same way, I try to evaluate how much extent my prediction is right. And if I find that I need to optimize, still I need to optimize on some set of parameters for me to classify or to make my percentage of evaluation of classification best, then I make use of some optimization techniques. Okay, so this is how the basic machine learning flow is. Representations, like if you have your uh, text data, I said vector space management. Maybe I can use a list of words with frequency counts. And then if I'm working with pictures, I make use of what do you call, your color pixels. I make use of images where I represent them in the form of pixels. And if I'm using some sort of other kind of things, I make use of attributes where maybe the colors, stripes, or one famous data set, iris data set, with which many of us work. So where I take the attributes like petal width, petal length, or sepal width, sepal length. So these are called attributes. So when I talk about the representations of your data, it could be in the form of frequency of words, it could be in the form of pixels, it could be in the form of set of attributes. So these are the different ways I can represent my I can represent my data, whatever given data is to me. And then next comes how do I do my feature engineering. It is not necessary that I consider the entire data or that is given to me when I'm working with any applied AI, or you call it a machine learning or a deep learning algorithms. So if you look at this, I have an array where my feature representation I have given, where I have the label, name, subtype, and many mask, width, height, color, score, all these things, right? So when I am trying to feed my learning model, it is not needed that I a label may not be required. Maybe name I can take as a classifier to some extent for prior learning or training your model. And then maybe I need my mass, width, height, and color score, and other aspects which are already there, the labor information may not be needed all the time. So feature engineering is one technique which is very useful, where it will try to help me first thing is which features need to be considered, and sometimes the data set is very high dimensionality data. If you have not needed that all the dimensions need to be considered, few dimensions may be skipped off. So that is one aspect which you can work with feature engineering, and you have many algorithms for that which you can apply, and then pre-process and then apply feature engineering, and then choose choose one or two or three, whatever the kind of algorithms you want, and then see which one works out better. Next comes to why do you think machine learning is hard? Because I am trying to incorporate the human knowledge into it. I'm trying to train my model based on some already available data. Like now here, this one example, if you can see, I generally say that apple should be the name of the fruit, and apple could be a corporation, and then the logo is like this, and then apple shape is like this, but there could be another one which is a peach, which is also in red color, which is also in round shape. So learning the model may what do you say, may not be may not do correct learning for few instances, and then so that is where your feature engineering, or how you represent your data and pre-processing of data, comes into picture. So this is where your challenges you have with your machine learning. Many people are working on feature engineering aspects into their PhD as part of their PhD problem area also. Now, this is the general model. When you got all of you are familiar, you need to get the data, clean, prepare, manipulate the data. You train your model, you test your data, and then if your test results or the accuracy of data is not that good, then I try to optimize or improve on the training model, changing some features, or I mean some of the values, some set of values I consider, and then I try to change. Okay. So yeah, this is one another important aspect which I want to talk about. Generally, test data in the initial stages, I have original data where I have divided it into your training data and the testing data. Maybe 80% is your training data and 20% you are taking your testing data. But then if you look at the KNN classification algorithm, it goes in a different way. It says K-cross validation is one technique that you can use, where I do validating data separately. Because if testing data is, the test data itself, if it is going to give you the result, that may not be an accurate result. I try to involve the entire original data as part of your training and validation, because this data is already known. The test data that you are considering is already part of your original data. So what I do is I eliminate my test 20% of data separately, and I use the remaining data. I divide them into training and validation. I apply all my, I apply the algorithms with different values of K, and then I try to judge the final performance evaluation with totally an unknown data, which is your test data. So this is one machine learning thing that you need to learn. You all are familiar. You have unsupervised learning and supervised learning. In case of unsupervised learning, you are dealing with clustering. In clustering, you have partitioning clustering, hierarchical clustering, density-based clustering, and many other clustering algorithms available. And then supervised clustering, classification and regression, where one works with continuous and other works with continuous data. So here in classification, you have SVM, KNN, random forest regression, logistic, linear regression, polynomial regression. So you have various regression methodologies that you can make use of. So yeah, in case of supervised learning, you all are familiar. I am not sure about the class label, and I don't have any knowledge about what to classify for clustering. But in case of supervised, I have an idea what is my class label and what am I working on, where am I leading to. Okay, so this is just a scenario of various machine learning algorithms that you have. Of course, maybe you all work with this, but there is one more algorithm that we need to look into, association analysis, where we have association mining, a priori algorithm, and FP growth algorithm. I would also say that Han and Camber is one really good book where we all actually started with what is called a data mining, which we are now calling as machine learning algorithms. We have added on definitely with something called as random forest, reinforcement learning, and all. But the core base knowledge we have already learned some from your Camber data mining, where we have association mining, where we learn a priori and FP growth also. That is also part of your machine learning. And then these are the various applications which of machine learning, where you have automatic language translation, speech recognition, traffic prediction, product recommendations, self-driving cars, virtual personal assistant, stock market trading and prediction, medical diagnosis. So these are the various applications of your machine learning. This one slide which already a ma'am has dealt. So here one thing is feature extraction is not part of the layers. It is done separately, and then I try to apply my classification. But then in deep learning, I am trying to embed both feature extraction and your ML technique, whatever you are using. Now, if I want to work with ML, the best thing is your Python. In Python, you have your SkyKit, where you have lot many algorithms where you can import your classes, functions, like your decision tree, KNN. All these algorithms are already available. They are built in and they are already there. And also few data sets are available. And then you have SkyPy, which will help you to work with any sort of mathematical computations, optimization functions, and all these things. NumPy, where you make use of arrays, multidimensional arrays. If I need to work with some array data, list data, and all, I can make use of NumPy. I also have pandas, where if I need to work with data frames, and if I need to read and write into data and all these things. I have matplotlib, which will Seaborn is also part of it, where I can analyze or visualize the data and come to some sort of conclusions. Okay, so these are all different kind of things that you have. I mean, different libraries that you have in your Python. And I would say Python is one beautiful open source software that you have, which has made the machine learning programmer or the machine learning people working with research into machine learning. It provides you a wide variety of such kind of libraries and built-in functions, which makes your job quite easier. Likewise, you have your BERT, LSTM, BERT encoders, everything embedded even with Python. So that also will help you a lot. So yeah, with this, I would like to stop. You have any questions, please?
One second, I'll unmute the participants. Actually, they're muted.
Yeah, please.
Okay, so participants can please ask queries if you have any now.